Hey guys, I just want to give you a little forewarning about this video. About halfway through, I realized I made an error, and so this video gets a little weird in the way it jumps around some. Okay, so do kind of pay close attention. I'm going to try to give you a little brief introduction to what my error is. In a second, you're going to talk about A values. Okay, and A is just how the graph either stretches, so either it gets skinny or how it gets fat. Okay, this is a vertical stretch, this is a vertical compression. Alright, this is assuming A is greater than 1. This is assuming A is between 0 and 1. And I'm gonna go over this all again. This is a 0. And you're gonna hear all this again in a couple seconds in the video. Alright, where it comes to play is as far as graphing, okay? So go ahead if you want to and jump down to D here. And I'm gonna do it again in the video. I'm gonna do it wrong one time. Okay? So when you have to graph y equals 1/2 x squared, well, the parent function is this graph you see right here. Okay, so that means there's been no transformations, which is going to make more in a second. This a value, okay, this a value, you're allowed to say that for one time from the vertex, which since I didn't shift left to right at all, it's right here, I can go over 1 and then I go up or down depending on if it's positive or negative. This was positive. I go over 1 and up whatever the a value is. Same thing here, over 1 and then up whatever the a value is. And now you could graph your quadratic function. Alright, so like on this one, I could go over 1 up 2. So I go over 1 up 2. Over 1 up 2. And sometimes the way I phrase it, it's going to seem like I didn't make any mistakes. But guys, I really did. You have to realize that the a value means that it's how I stretch or compress, and I'm allowed to always go over 1 and then up or down to whatever the a value was. Okay? Alright guys, really do try to pay attention. It does get a little confusing. I do apologize for that. Thanks. Hey guys, we're going to go over transforming quadratic functions. Alright? So quadratic functions is kind of our next topic that we're going to focus a lot on. Alright. So you should have this packet out in front of you. It should have been given to you by the sub. And so quadratic functions actually have a couple different ways that you can write their forms down. But for today, we're going to focus on what is called the vertex form. Okay? So the vertex form is y equals a times x minus h squared plus k. Okay? So what's important to remember now, so that is what you should write here for number 1. That is vertex form, okay? So on question 2, when it says be specific, name 2 ways that parabola changes with different type of a values. Well, if a is greater than 1, we have what is called a vertical stretch. So I'm just going to write VS, but it stands for a vertical stretch. If a is between 0 and 1, okay, so 0 is less than a, but a is less than 1, then we have what is called a vertical compression. Alright, so remember, a vertical stretch just means we take something that's like normal, so this is kind of what a parabola looks like, it's very poorly drawn, and if we were to stretch it, it gets longer and skinnier, but if we compress it, it gets shorter and fatter. Okay, now one other thing you should be aware about a values. What if, so when you look at what we've written down for a, you'll notice that a is never negative in either one of these situations. Okay, that's because a being negative does not affect if it's a vertical stretch or it's a vertical compression. If a is negative, all it does is tell me that it reflects across the x-axis. So out here to the side, I would write if a is negative, it means a reflection across the x-axis. Okay, so that's all I was talking about. So, what is changing the h variable do to the graph? Well, if h is positive, a positive h means I shift the graph to the left. Shift left h units. Okay, you should kind of be remembering some of this stuff. We've talked about transformations earlier on this year, but now we're talking about transformations specifically in regards to the quadratic function. And if it's a minus h, that means right h units. Okay, so it says what is changing the k variable do? Alright, well k is just simply how up or down I go. So a positive k means up k units, so a positive k means up k units, and a negative k means down k units. So if k is negative, it means down k units. A negative k means down k units. Okay? So let's go on to problem number 5 here. All right, problem number 5. Using the graph. All right, so I tried to give you a little bit of help here. Let me get rid of this. Let's see if I can. For some reason, it's not letting me select on this. There we go. Okay. All right, so here it says, whoa. All right, using the graph f(x) equals x squared. That is the parabola you see right here. Okay, so the red parabola, it's actually not red, it's black. It's red on my screen, but it's black on your paper. This parabola right here is the f of x equals x squared parabola. Okay, so that means that is the parent function. So if there has been no transformations, this is what the quadratic function looks like. I'm going to say that again to make sure you listen to it. If there are no transformations, this is what the quadratic function looks like. The quadratic function is just another name for the f of x equals x squared function. Alright, so what it wants us to do is it wants to describe the transformations and then graph each function. So let's look right here. Y equals x squared plus 2. Okay, we have added a k value of plus 2. So then our new graph is going to look just like this, but it's going to shift up 2. So we're going to keep the same look, but we're going to shift up 2. Okay, and there we go. So I'm not going to do B. If I were you, I would take a second, I would pause, and I would try to do B. But we're going to move on to part C. Oh, shoot. I went too far. Part C here. All right, it says y equals 2x squared. Okay, so we've added an a value. This a value is 2. So a equals 2. It is bigger than 1. So if you look at your notes just above, if a is greater than 1, that's a vertical stretch. Okay, it's a vertical stretch by 2. So that basically means I'm going to cut this guy in half, and what I mean by that is basically it's going to look something more like this. See how I'm trying to make it a little bit skinnier? See how I'm trying to change the skinniness of it? Okay. And so that's the basic idea of what an a value does. Hint, on this one, it's going to make it fat. So instead of being like this, you might want to think about it going through these 3 points and what that would look like. Okay? The reason I know these 3 points is I look at this number right here, 1/2. If you look at your a value and you go to your vertex, okay, now that's a new word. I'm sorry, I should have explained this word earlier. Vertex is the starting point, excuse me, on your parabola. Okay, in fact, write that down somewhere at the top of your page. Vertex is the starting point. Another way we talk about vertex is it is the max or min of a parabola. Write that down, okay? So the vertex, you kind of see it as your starting point, but it's also either the maximum or minimum. Now, in these 4 graphs you see on my screen right now, the vertex is all at the origin, okay? This blue one's a little shifted out. But the vertex is at the origin here still, but up here we actually moved the vertex to being, when we did this graph a second ago, I know it's already erased, but when we did this graph a second ago, we had moved the origin now to being from 0, 0. We had moved the vertex from being 0, 0 to being at 0, 2. Okay? So, think about that in reference to this graph, alright? The reason I know it's going to be at these points specifically is I look at that a value, and I started my vertex, and this only works one time. You can only do it for 1 point. It's not like linear where we could do it from the new point to the new point to the new point to the new point. But from the vertex, you can look at your a value and you can do rise over run. Alright, in both directions. So you can go up 1 over 2, up 1 over 2. And over here you'll notice I did 2 over 1 and I went up 2 over 1, up 2 over 1. Okay? You cannot do that again. It does not work a second time. It's not like lines that we were doing earlier this year. Okay? Alright, so let's try moving on. Let's try going down some. Alright, come on, stop. Sorry, my screen's being weird. Okay, it says y is equal to x minus 2. Well, that's an h value. That h value means I'm going to go right 2 units. So that means my vertex is going to go from being at 0, 0 to being at 2, 0. My a value is still 1. Okay, so that means I know from the vertex I can go up 1 over 1, up 1 over 1. Remember, I cannot do that a second time. I can only do it 1 time. But it allows me to get 3 points to graph my parabola kind of nicely. And there we go. Okay. Alright, let's go down some here. Let me see if I can't just guide myself down a little bit. All right. So this one, we actually have a little bit more changing. All right, we're going right 1. That's what this -1 with the x means. It means right 1. Since it's a minus h means right h, and this is a -1, so it means right 1 and up 1. So our vertex is going to go from being at the origin, it's going to go right 1, up 1. My a value is still 1, so that means from the vertex I can go up 1 over 1, up 1 over 1. And I cannot do that again, but now I can make my parabola. Okay? Alright, let's go down. Alright. So, negative x minus 2 squared. Alright, so now this guy has a couple things going on. First, we are going to the right 2, but we're also reflecting. We're also reflecting, okay? So our a value is a -1, but remember, I ignore the negative when I'm determining vertical stretch, vertical compression. So as far as vertical stretch, vertical compression, I look at this as just 1. Well, 1 means there's no vertical stretch or vertical compression. So then the negative sign, because from right here, tells me that it reflects. But I'm also going to the right 2. So I go right 2. My a value is basically a -1, so it means down 1 over 1, down 1 over 1. And it should look something like this. And there you go. Okay. Moving on. Okay. Write the quadratic function in vertex form for each graph. Remember, vertex form, you already have it written down, is y equals a times x minus h squared plus k. Okay? So now, change colors, find your vertex. This is how you do this problem. You find your vertex. My vertex is at 2, 0. So that means I've shifted right 2. So I know that h is actually 2. And I know the k, well, that's 0. I didn't go up or down at all. Now, did I change my a value? Start at your vertex. Go up and over to your next point. Go up as many as you need to and over as many as you need to, but go to your next whole number point. Up, over. Okay, so I went up 1 over 1, and I landed at my next point, so that means my a value is just 1. So then I can write x minus 2. So y equals x minus 2 squared. Okay? Let's try to do, I'm going to try to do number 9, okay? So when we look at number 9, we find our vertex. It's right there at -3, -5. So I'm going to write y equals, all right, if I'm at -3, that means I went left 3. So that means I need to write x plus 3, because going to the left means I'm adding my h. Okay, and then I went down 5, so I say -5. Now we need to check the vertex and the a value. So we start at the vertex and we go up. So to get to our next whole number point, that's going to be right there. We don't want a half of something. We go to our next whole number point. Okay, so that's up 2 over 1. So if we've gone up 2 over 1, that means our a value is 2 over 1, which is just 2. Okay, let's move on some. Okay, let's look at number 11 together. Once again, still same question. So, look, if I had moved from the origin, nope. So that means both h and k are 0. Alright, but you see how now I reflected? So that means I need to have a negative sign. And then I'm reflected downwards. Alright, so I have the negative sign, but now look, start at your origin and count to your next whole number point. Down 2 over 1. So once again, it's -2 x squared. There was no h, there was no k, so that's I just write x squared. Alright? I'll give you a hint on this one. The a value is going to be something like down 2 over 1, 2. No, that's not right. Hold on. Sorry. I'm struggling to read, just like I'm sure you will. Down 1. No, it is down 2 over 2. Oh, okay. So that's just going to be an a value of 1. I thought that guy looked a little bit fatter, so I thought it was going to be a vertical compression. But I must just be looking at it wrong. Okay. Well, no, that can't be right. Okay, so I'm going to have to learn how to edit. But I just paused this video and was doing a bunch of reading to make sure I remembered something correctly. And I did not. So I'm going to figure out how to edit this back in. Okay, So far, my trick has worked on every problem by accident, okay? Because what you're supposed to do, all right, is simply always start at the vertex. So in order to find the a value, okay? So in order to find the a value, what you're always supposed to do is to start at the vertex, go over 1, and then go down however many. So when you're looking at problem number 12, I went over 1, down a half until I hit the line, okay? So over 1 down a half would be 1/2 over 1. Well, what is 1/2 divided by 1? Just 1/2. So for this problem, a is equal to 1/2. Okay? So then, for this guy over here, it's still going to be -2. That's still right, because it's still reflected, so I'm still going to add the negative portion. Okay? But this one, I'd go over 1, and then I went down 2 until I hit the parabola again. So, over 1, down 2, 2 over 1, you always do rise over 1 still. And that still gives me 2. And it was still negative because it was reflecting. So what we've done is worked, but I've just been saying it wrong. Okay? So I'm going to try to learn how to edit so I can at least throw this in. So this video is going to be a little confusing at times. Have fun with it. You know, it's just like my class. Alright. Let's move on to next grouping. Alright, it says graph this quadratic equation function, describe the transformations. Well, this -4 is not in a parentheses, so that just means down 4. And so I just take my graph, I go down 4. My a value is 1, so I know I can go over 1 up 1, and then I can go over 1 up 1. And then I'm ready to rock and roll. Okay, and there you go. Alright, so I'm not going to do any more of those because I think you can do that. I think you got the right idea. Alright. And I apparently have a bunch of blank pages. So, that is the last set of problems. Okay, guys. I'm sorry that this video got confusing at times. To go back to where it got confusing, which was working out the a values, okay? Which was talking about the a values. Alright, so I'm going to go back to this problem right here on D real fast. Alright. Again, I apologize that I got confusing, but 1/2 x squared, how would you graph that? Okay, well, the origin has not changed, and then you're going to go over 1/2, I'm sorry, you're going to go over 1 up a half. Over 1 up a half. And those are your 3 points. Okay? And there you go. Alright, so again, regarding the a value, the a value is not going to be as big of a deal as I'm making out to be in this video, okay? The only reason I'm making it out to be a big deal is I thought I had a nice little fast trick, and then I couldn't remember it exactly, and so I kind of made a mistake. But I guarantee you the a value is not going to come back to haunt you as much as this video is making it out to seem, okay? Basically, the idea here is that simply the a value, you can just simply always assume that you go over 1 and then up however many or down however many the a value is, assuming it's positive or negative. Okay? This video got long, guys. Please, please, please send me a remind with any questions. Send me an email. Send me a message over Canvas. Please make sure you're working on this. Thanks, guys.